All right, so here we go. I've got some problems I want to just quickly zip through with you. So I put up another short review with just a few more problems that I didn't get on the first one that I really want you to do. Of those problems on the second review, most of them literally will take you like 30 seconds to a minute. There's a couple though that will take a little longer, and those are the ones I want to go through. On the first review, it's pretty obvious to me where we need to look at this. It's not surprising. It's the problems like this, right? Yeah. The ones where, well, and they're all going to be, once we do a couple of these, they're going to make more sense. But I need to remind you about a couple things. So let's go through this one. We know that it tells us the coordinates of point A. We're told the coordinates of point C. And we're told the length of side BC in this triangle. Now, if angle ABC is equal to 90 degrees, then angle B, the shortcut way of saying that, is the right angle, correct? So if I were to draw this right triangle, and I'm not going to worry about trying to make the coordinates good. And I'm not really going to try to make this thing look like it would if I were to graph it on the coordinate plane. It's not really important. All we need to do is just write it in terms of a right triangle. So then we know that the coordinate of the right angle is B, and so the other two are just A and C, right? Now let's just plug in the stuff that we know. So we know BC is 18. We know that if point A has coordinates 6, -3, and C has coordinates -8, 9, can't I use the Pythagorean distance formula to find that distance pretty easily? Right? So let's do that. Okay, so we end up with AC then just equals the square root of delta x squared plus delta y squared, right? What's delta x between A and C? Yeah, 6 minus -8, so 14, right? Plus, what's delta y? 12, 9 minus -3, okay? So we end up then with the square root of 196 plus 144 equals the square root of 340? Okay, so we know the length of AC then, right? The hypotenuse is the square root of 340. Now what are we looking for? AB, right? So AB ends up just being the missing side of that triangle, doesn't it? Everybody agree? Okay, so how can I set up an equation then to solve for AB, or we'll just call it x? Pythagorean theorem, sure. I know that x squared plus 18 squared must equal the square root of 340 squared, right? Or in other words, we get x squared plus 18 squared is, what is that? Is that 324? Yeah. Okay. Equals, what's the square root of 340 squared? 340. Right? Go away. I need down there. Go away. Oh, jeez. Really? Why is it doing this? Why is it doing that? Oh, there we go. It went away. Okay. All right, so subtract 324 from both sides, and we get x squared equals 16, right? Okay, so what are the solutions to that? Everybody agree? If I square root both sides, I get x equals plus 4 minus 4. Okay, everybody focus up here, please. We got a lot to get through. I want to make sure everybody gets a good shot at all this. So plus and minus 4. So then we want to know what is AB. Well, which one of those makes sense? 4. Positive 4. Negative 4 we can abandon. So if I write those as either plus 4 or negative 4, the negative 4 we get rid of. It doesn't make sense in a geometry situation, right? It is, algebraically, it's a good solution. It makes sense. The math gods answered our question when we asked what's the solution in terms of x. But now we've got to take those answers and go back to the context of our actual geometry problem and say, okay, you know, which of those really work for us? And only the positive 4 does, right? Make sense? Okay, questions on that? How to get to 324? Oh, that was just 18 squared.
Oh.
Okay, yeah. So we just used this squared plus that squared equals that squared. Okay, make sense?
Yeah.
Okay. All right, moving on. Something like this. I changed the wording on these a little bit. There was a issue with this problem. I didn't really like it the way it was previously worded. I don't know if that'll show up when you go back into your assignment or not. But if you were to redo it, which I don't want you to do, it would show up. But answer it as though it were this question. Okay. So it may be x's, it may be y's, but it'll be the same kind of a deal. So they give us the coordinates of point A, they give us the coordinates of point B, and they tell us the distance between A and B, right? We're supposed to, the question asks, what values of x would be mathematical solutions, okay, to the quadratic equation you set up? Which values of x would you have to check? So in other words, not all these values of x might produce geometrically sound answers, but I just want to know, if we get into the algebra equation here that this geometry prompts us to do, what are the values of x that we get? We won't go so far as to actually check them and find out what the length of AB is. We already know that, I guess. But I just want to know, what are the values of x that the algebra equation gives us? I don't think this is a very good question in that sense, because it'd probably be better if it asked maybe just for the values of x that work, but it didn't do that. So I won't put this one on the test, because I don't really like it. But that's how you do it on the review, okay? So how do we go about this then? What's our well, you tell me. If I'm trying to find a distance, to us that's just Pythagorean theorem, right? We always think of the distance formula as being a Pythagorean relationship. So we've got point A. I'm not drawing this to scale. I'm just drawing it to represent the situation. There's point B. I don't know if that's right or wrong, you know. But if that's the case, then that's delta x and that's delta y, right? And the distance between the two is 5. They already told us that, right? Make sense? Okay. We can calculate, well, we know the coordinates of A and B. B has an x in it that we're trying to solve for, but we know A has coordinates 5, -1. B has coordinates x, comma, -5. So what is delta x for us then? Either 5 minus x or x minus 5. It doesn't really matter. Good luck, guys. Take it to them. So delta x is x minus 5, let's just say. I'll put this, as soon as I'm done with this, I'll put it up on YouTube, so if you guys want to look at it, you can. Okay. So what's delta y? Okay, so yeah, so which one do we want to do though? We want to always make a positive answer, right? So we always do the bigger, the greater minus the lesser. So -1 minus -5 is what? Positive 4, good. So delta y is 4, right? Say it again.
It has to all come from the same pair.
No, it doesn't.
But the first one has to go first.
Doesn't matter, huh? Because when you square them, they're all going to be positive anyway, right? Does that make sense?
But
No, he's saying that if you take the x value minus 5, like how we have the first one.
Then you're saying you'd have to do -5 minus -1. But you don't. You don't, because it's not like a slope. Because a slope is not being squared. With a slope, you do. But with this, here's what I want you to do. You might have been taught that before, but that's not correct. You don't have to do it that way. Because in the Pythagorean theorem, delta x and delta y are being squared, right? Does that make sense? And so whether they're positive or negative is irrelevant. So it's always easier to get the positive one, and it really makes sense in terms of a triangle, doesn't it? Because the sides of a triangle are always positive. The lengths, you see what I'm saying? So really, there's your justification, but mathematically, you're much less likely to make a mistake by not putting the negative number in parentheses and squaring it. You know what I mean? I mean, everybody does that. Yes, sir?
When determining delta x and delta y, wouldn't it be easier to just take the 2 points and see how far they are away and
Well,
just values on number line?
Yeah, you can. That's fine. You absolutely can. That's what you're doing when you subtract the smaller from the bigger. It's exactly what you're doing. But if the numbers are really bizarre numbers, maybe that's hard to do in your head if they're decimals or something, right? So this is in practice what you're doing. You're right. So there's delta x, there's delta y. What does our Pythagorean distance relationship tell us then? Yeah, so we know that the distance is 5, so we know that delta x squared, so that's x minus 5 quantity squared, right? Plus delta y squared equals hypotenuse squared, right? Everybody agree? So all I've got to do then is solve that. Now, you guys we haven't introduced some patterns yet. Do you know the pattern for multiplying out a binomial like this, for squaring it?
Wait, don't you have to multiply it like negative x?
You do, right. So exactly, and that's what you can always do. We can just write this as x minus 5 times x minus 5 and FOIL it out, and that's fine. You can always do that. There is a little pattern, just so you know. We'll talk about this more later. If I do something like a plus b quantity squared, it always just equals a squared plus 2ab plus b squared. You don't have to remember it, but that works every time. It always works. And so for us, like for example, a was x and b was negative 5, right? So what are we going to get from this? We're just going to get x squared plus 2 times x times negative 5, so minus 10x, right? Plus negative 5 squared is 25. So it's just a shortcut, but you certainly don't have to use it, right? What else do we have? So plus 16 equals 25, right? And so then, let's see here. Did I do something wrong there? Did I? Oh, okay. I guess that's right. I guess everything's right. I got the x and, no, that's good. Negative 5. No, I guess we're good. We're good. Okay, never mind. So if I combine all this stuff, but now here's the thing. If I want to solve this equation, notice I've got x squareds and x's in it, right? So remember talking about this at the beginning of the year. This is not a normal equation. We can't isolate x, right? So what we have to do instead is we have to put it in standard form. We're just going to combine all the terms on one side and set it equal to 0, right? So we end up with x squared minus 10x, and then I get what? Plus 25 minus 25. Those cancel, so I just get a 16. Plus 16 equals 0, right? Okay, so now what? Oops. Okay, here's where we have to factor and use the zero product property. This is good stuff. Whenever we want to solve a quadratic equation like this, we're trying to find the values of x that make this equal to 0. Well, we're never going to find it just by randomly picking values. So right now, I'll teach you some other ways of doing this later in the year. But for now, the only way we know to do this is by factoring and setting the factors equal to 0. So I'm only giving you problems that you can solve by factoring, right? So what does that factor into? Okay, good. X minus 8 and x minus 2. Make sense? Okay, and remember that little thing we talked about where the only way you can multiply stuff and get an answer of 0 is if you multiply by 0, right? So there are values of x that could make the first factor equal to 0, which would work, or that could make the second factor equal to 0, right? And so all we have to do is just find those values of x. So we're really just answering the question, where does x minus 8 equals 0? So that's one solution we're going to get, is when x minus 8 equals 0, or when x minus 2 equals 0. So what's this solution? 8. So either x equals 8 or x equals 2. So now, yeah, there we go. That's a little better. So now we just have to go back and see which one works. So let's see. Okay, so what do we get? 8 or 2? So delta x, oh, that's the answer, never mind. That's all we're looking for is the two values. I didn't ask you to go any further, right? I just want you to find the x values. Thinking about this logically, yep, Joe?
What was that whole A and B thing? Where it was like 2A squared.
Oh, I erased it. Oh, this, I'll write it again though. Here it is, just this. A plus B squared equals A squared plus 2AB plus B squared. If you want to use that, it's handy. Okay. If we actually plug these in, look what happens. If I plug in 8 for delta x, or for x, I get delta x equals 3. Okay, so that would make this side length 3. That works, doesn't it? If I plug in 2, I get delta x equals negative 3. Can you have a side length in a triangle that's negative 3? No. So in reality, we would have to discard the x equals 2 solution. That's what we call an extraneous solution. The math gods gave it to us, but it doesn't apply to our situation, right? But for you guys, I want both. In the question, I want both, right? Questions on that? Okay?
It's a perfect triangle.
Say it again.
It's a perfect triangle for the form.
Yeah, it is, right, you're right, Pythagorean identity, you're right. So what about this one now? Same kind of a thing. You're gonna see that these are just like a broken record. These all are producing. The geometry, you have to be able to interpret the geometry, but you're getting algebra equations that are all pretty similar. So if f is between E and G, does everybody agree that the distance EF plus distance FG equals distance EG, right? So then we can set up a pretty simple equation there, can't we? We could just say that negative 6x squared minus 3x plus 10 equals that plus that, right? So negative 8x squared plus 7 plus 4x plus 7, right? What do we want to do with this, being as I've got x squareds and x's? Equal to 0. Put it in standard form. Now this is also kind of important. It'll work both ways, but it's much easier to put your equation in standard form so A is positive. So which side do we want to push everything to?
Wouldn't you just go 4x plus 7 minus 8x squared plus 7 equals minus 6x squared minus 3x?
Yeah, so over here you mean combined like terms? Is that what you said?
No.
Okay.
Because like the top two equations with them equal to the bottom equation.
Yeah, we did. So the bottom equation equals the middle equation plus the top
Okay,
equation.
you wrote it backwards.
Yeah, I did write it backwards, you're right, yeah. The only reason I did that is so the x squared is first, but it doesn't matter. We want to push everything to the left though, don't we? So I get a positive number of x squareds. So if I do that, I'm going to get, you told me 2x squareds, how many x's am I going to get?
1.
I got to subtract 4x, so
Oh, JK.
good, minus 7x. And let's see, I've got 14 over here, I got to subtract 14, so I get, okay. So all we got to do then is just factor that thing, right? What are our options? Well, we know we can't factor out a greatest common factor, so this is what we would always have done as a bottoms-up problem, right? Which you can do, that's fine. There's another option for you too, though. Just bottoms-up works great. If you're more comfortable, just do it. But because the 2 is such a simple value for A, it's really only got 2 convenient factors, right? 1 and 2. This is one where we could maybe just kind of finesse our way through it and just sort of guess and check a little bit and get the answer quickly, right? So we could just go, we know it's got to break down to something like 2x and x, right? And then I just got to pick factors of -4 that are going to FOIL properly, right? And so I could just, guess and check. I could just go through and try them. There aren't that many possibilities, are there? But if I know that when I FOIL this out, I want to get the outside product and the inside product to add up to -7, doesn't it make sense that I'm going to want to do a -4 and a +1? So I'm going to get a -8x plus an x. You kind of see that? And what if I got it wrong? I could just try. I don't have many options to try. I could either put -4 there, +1 there, +4 there, -1 there, -2, +2, +2, negative. There's only 4 things to try. One of them's going to work, right? So you take your pick. When it's easy like that, you can always do bottoms up. It's going to work, but it might be quicker just to do this, right? Maybe for now, just do bottoms up. But as you kind of work through stuff on your maybe not on the test, right? But when you start working through stuff in the next few chapters, try doing this a little bit because you'll get good at it and it's easy. Yep.
How did you get one and negative?
How did I get one? Because I have to have numbers that multiply to -4. Does that make sense? Because think about how I'd FOIL this out. The first times the first would have to be 2x squared, and the last times the last would have to be -4, right? But go for bottoms up. Bottoms up will work great too. I mean, if you're more comfortable, like I say, just do that. Now that I've got these though, let's apply the zero product property. So the two options are to get a product of 0, either 2x plus 1 equals 0 or x minus 4 equals 0, right? So what's the solution over here? -1/2, I gotta subtract 1 and divide by 2. So x equals -1/2 for x equals 4. You guys have to check them both to see, they're actually asking in this case for the lengths of the segments, right? So I gotta see which ones make sense. Let's try, what if I try the 4, for example? You see any problems? Well, the first one seems to be okay, right? I'm getting 4 times 4 is 16 plus 7 is 23. That's fine. But look what happens to the second one. -8 times 4 squared. That's a big negative number, isn't it? Agree? So that big negative number plus 7 is still just going to be some big negative number. That doesn't work. How can you have a segment with a negative length, right? See what I'm getting at? So the positive 4 value of x, you got to discard that one. It didn't work. It gave us, if I plug it into FG, I'm going to get, what am I going to get? -128, so -121. I'm going to get that doesn't work. FG has to be positive. It's the length of a segment, right? So what about -1/2? Let's try that one. If I plug -1/2 in for x in the top one, what's 4 times -1/2? -2 plus 7? 5, good. So -1/2 squared is what? What's that? Positive 1/4. Okay, so -8 times 1/4 is what?
-2.
-2 plus 7, 5. And let's just make sure that the last one works. -6 times x squared, well that's going to give us, let me scoot down a little bit, that's going to give us -6 times 1/4 minus 3 times x is -1/2, right? Plus 10. What's -6 times 1/4? Which is the same as -3/2. Good, so we get -3/2. What's -3 times -1/2?
Plus 3/2.
Good, plus 3/2 plus 10. Those cancel, so I just get 10. Right? And it works. Make sense? Okay? Questions on that? So in review, all we did was we just used the segment addition postulate to set up a quadratic equation. We put it into standard form, and then we solved it by factoring and applying the zero product property, right? Setting the factors equal to 0. We had to check both of those values though, didn't we? Right? So we had to try both x equals 1/2 and x equals 4. Now if we had tried x equals 1/2 first, we would have just gotten an answer that works the first time and it would have been done, right? We wouldn't have even had to try the other one. Make sense? Okay? All right. This one I'm not going to do. You guys can do this one. We did one like this on the assignment. All you have to do is just draw the picture well. I'm not sure I'd want to put this on the test anyway because it takes a while to do it. I'm not sure. I'm kind of leaning against it, but you got to do it on the review at the very least. Just draw the picture well. The first draft of the picture may not be drawn to scale, but then draw it with the appropriate angles and you'll get it. That one's not a big deal. Same thing with this one. This one, on the test, I'll tell you this. On the test, I'll give you a problem like this where the points are graphed on an XY plane, which makes it a lot easier. On this one, what you'll have to do is you'll just have to get a piece of good graph paper, and I'll go get some when I'm done with this, so you can even take some with you, some of that really good graph paper we have. And you just have to plot these points. B is the vertex, isn't it? Right? Because it's angle ABC. And then just carefully draw draw the angle and see which of these points are actually inside the angle or in the interior. But it's not a hard problem, it just is a little time consuming. It'll be really quick and easy on the test though, because I will have it drawn for you. But I just want you to understand what interior versus exterior is. Easy problem. Questions on either of those two? Okay, I'm not worried about them, they're fine. This guy, okay, this one comes with a picture, but we don't really need the picture for this part. If we know that we've got the measure of angle FQG, the measure of angle GQE, and the measure of angle FQE, notice that Q is the vertex of all of those, right? And so doesn't the angle have to look like this? There's Q, there's F, there's G, and there's E, right? Does that make sense? That's the only way we can draw it. And so then how do we set up a relationship here? Yeah, so it's this little one plus this little one equals the big one, right? Same kind of issue we dealt with before, isn't it? If we have time, we can come back to it if you want to, but this is going to be the same kind of problem, isn't it? We're just going to get this plus this equals this. It's going to give you a quadratic equation. You've got to put it in standard form, solve it by factoring, see which ones work, right? Okay, no big. If we have time, we can come back, but I want to show you this one first. Okay, this one also comes with a picture. The picture, in fact, maybe I need the picture on that one. Well, okay, it goes like this. I can sort of draw it. This may not be to scale, but it's going to look like where this is R, this is O, there's O, there's T, this is W, and this is Y. Okay? So what are some relationships here that we know about these angles? I'm just going to label them. Let's just call this one angle 1. Let's call this one angle 2 and that one angle 3 just for short. Okay, 1 and 3 are congruent, aren't they? Because they're what? Vertical angles, okay. What else do we know?
2 and 1 equals 180.
Okay, 2 and 1 are a what? They're supplementary. What do we call that relationship though? They're a what? Linear pair. Good. So 1 and 2 are supplementary, so are 2 and 3, right? So now look at the situation here then. We've got, I want you to notice each of these angles. This is a great problem. This is going to challenge you just a little bit, but this is a great problem. So this first angle, it involves both x's and y's, doesn't it? The second one also, x's and y's. Third one, x's and y's. So think in general. If I want to be able to solve for 2 variables, how many equations do I need?
2.
I need 2. I need at least 2, right? I need at least as many equations as I have variables. So I got to be able to set up 2 equations, but I've got 2 geometry relationships to exploit, right? I've actually got 3, but I only need 2. So one of them would be, I could set angle 1 and angle 3, and that's just this guy and this guy, right? I could set them equal to each other, okay? So let's do that. So we've got, I'm going to do this on another page also, just so I can write more. Okay, so this was, from the last page, this was angle 1, that was angle 2, and that was angle 3, right? So we know that 3x plus 2y plus 44 equals 5x plus 4y minus 26. Okay, so why don't I just make this into a linear equation in standard form like we dealt with earlier in the year, right? When we solved those linear systems. Let's put the x's and y's on one side. So I'll subtract 5x and get negative 2x. I'll subtract 4y and get minus 2y. And I'll subtract 44 and get what, minus 70? Okay, everybody see that? Right, all I did was I just moved the x's and the y's that way and the 44 that way, right? Okay, everybody agree? So there's one equation, nice convenient equation that we can use to solve our system. Well, you also told me that 1 and 2 were a linear pair and therefore supplementary, right? So we could set up angle 1 plus angle 2 equals 180. So we could say 3x plus 2y plus 44 plus 6x plus 6y minus 164 equals 180, right? So let's combine the x's and the y's on this side. So I get, what, 9x, check my work here, 8 plus 8y. 44 minus 164 is what, negative 120? Let's add that to the other side and get 300. Oops, that's 300. So now look, I've got 2 equations and 2 unknowns. So how could I solve this system?
So much douche. No.
I could, well, I mean, I actually could, but it might be easier to just multiply the top one through by what? 4. Yeah, everybody see that? If I multiply it by 4, I'm going to get a negative 8y and a positive 8y, right? So let's do that. So then that's going to make the top equation negative 8x minus 8y equals negative 280. The bottom equation is just 9x plus 8y equals 300, right? And so now we can just add those up, and the y's cancel, right? And I just get, wow, x equals 20. So there's half the battle, right? X equals 20. To get y, I'll just plug that back into one of my originals. How about that one? That's an easy one, right? So negative 2 times 20 minus 2y equals negative 70. So what is that? Negative 40 minus 2y equals negative 70. What are the 2 steps in order to solve? Add 40, and then divide by negative 2. So I get negative 2y equals negative 30, so what's y? Good. So what do I have to do with those then? Well, actually, I guess it asks for x. So the first answer is 20, second answer is 15, and ORT, I would just plug them in, right? So what's that going to give me? 3 times 20 is 60, plus 2 times y is another 30, so that's 90, plus 44 is 134. Everybody agree? Okay? Make sense? Okay. That's a pretty good problem. Now, you might see one easier than that too. Like that would be easier, same kind of a problem, but just we don't have to do the whole thing, but just tell me why this one would be so much easier. Ah, okay, you already see it. Good. You guys are so smart. This is awesome. That's right. So this is like D, V, E, Z. Yeah, look at that. So now we can set up equations with only x's in them, for example, right? We've got minus 14x minus 3 degrees, negative 11x plus 30 degrees. If I set those equal, I can solve for x, right? Got one variable. So even though I've got y's up here, that's going to be easy to solve for, isn't it? Because if I knew what x was, couldn't I figure out what the size of that angle was? And so this one would just be 180 minus that, right? I could solve that one easily without having to do anything fancy, make a linear system, right? Make sense? Make sense? Okay, questions? Okay? All right. I think we're good. Do we have, how much time do we have?
9 minutes.
9 minutes? Is it probably not worth getting those out, is it? Okay. All right. So are we okay to go with this tomorrow? Are we feeling? Be honest. Are you feeling a little?
Wait,
Okay.
Friday.
Yeah.
I haven't finished the study guide yet, yo.
Okay. So I'll tell you what I'll do. I'll tell you what I'll do. I don't want to stress you out. What if we just did Monday instead? That'd be better. So you could have tomorrow and the weekend to Would you feel better about that?
Yeah.
Okay, would it be, and I want you guys to be honest with me. Tomorrow, I just got the feeling tomorrow was people were feeling like that wasn't a good thing.
Everybody's gonna be messy, so nobody's gonna be concentrating on anything. And we're gonna have short
Yeah, and
class
tomorrow's
periods.
homecoming too, so maybe tomorrow's a bad day.
And we have short class periods.
Yeah, okay, that's okay though, but even if it's shortened class periods, we could still get through, maybe I'll put it into two parts or something, so we could do one part.
I don't want Monday.
Okay, what I would do is this then. Here's the other plan we could do. I do this sometimes in my physics class or my calculus class. I would do this. If you guys wanna wait and do it Tuesday because Tuesday's a longer day, I'm okay with that, but Monday I'm gonna maybe start introducing some new material that won't be due till later in the week. You okay with that?
Yeah.
Okay, so we'll set the date as Tuesday then. So the reviews won't be due until Tuesday at the time of the test. And that should be plenty of time. You got unclenched a little bit? Feeling okay about that? All right.
Otherwise, I'd have.
Well, this, honestly, you guys don't blow this out to be more than it is though. It's not, you're not gonna have, you'll be able to sit down. I'm really pretty comfortable saying that I think, maybe between now and then at the most, you're gonna have a couple hours of stuff to do. I don't think it's gonna be a big deal. I really don't. You'll sit down, you'll go through these, you'll know if you're getting them right, you'll be able to ask questions on Monday, right? We'll have a lab day on Monday. So you should be fine. You really should be fine. I think you will. Don't stress. Remember also, people don't learn well when they're all stressed out. You don't have to be stressed. You're gonna be able to retake these tests, right? That's part of the reason I do all this stuff with Moodle, is so I can offer more than one retake, right? So I'll give you, let's say, I'll give you 3 retakes after your original take on this. How's that sound? So that should eliminate all the stress, right?
Yes.
Okay.
Unless you're on your last retake.